Hello, everyone. Thank you so much for the introduction and the invitation, Trisha, and also Chris. So I'm gonna, as you already know, I'm an architect. I study architecture and fine arts. And for the past few years, my work has been focused on radioactivity. I've been studying extreme environments where radioactivity has generated really specific territories, such as Chernobyl or Fukushima. And I've been studying extreme environments, and then I became interested on the small doses that we can receive in our environment. On average, we receive 3.7 microsieverts per year, but in any case, we are exposed to radioactivity from nuclear activity, from the radon, that is the radioactivity that is emitted by buildings and construction materials, and also, as you know, from the cosmic radiation. And I was impressed about how radioactivity works and how its invisible properties, how it goes through a wall, it interacts with our body. So all these properties and characteristics of the radioactivity really impressed me as an architect, right? So for me, it was really important the work of an artist that in '69 buried radioactivity in Central Park, and he understood radioactivity as a material. And he said that a lot of things can be done with this incredible material, and it is just letting it do what it is supposed to do. So how we can deal with radioactivity, how we can interact or as a design infrastructure dealing with the invisibility of it. So I've been developing a series of projects that I call them exercises that in a way help me to understand radioactivity. So in this case, for example, I use a sensor, a Geiger counter, and I introduce it into a concrete block. As you already know, concrete is the most high density material to block radioactivity together with lead. So in a way, I try to represent introducing the Geiger counter inside the liquid concrete once before it's dry to represent the quantity of material you need to insulate the radioactivity in the environment. So another project that I brought it here, it's a device that it also has a Geiger counter that it measures the radioactivity and it moves following the radioactivity in the environment. So this is another tool that helps us to represent the invisibility, because what it's important for me is how we can monitor radioactivity, how we can, from an artistic research approach, we can represent, listen, or visualize the invisibility of radioactivity. I also have other projects that we can discuss it later, choreography, where together with Buto dancers, that Buto is an artistic movement that appeared in Japan after the atomic bombs. So together with these performers, each performer is carrying a Geiger counter, and they represent the radioactivity through the movements of the dance. So in 2014, I started a project that was actually my starting point of my research, and the reason why I'm here it's about Chernobyl. And as also the rest of the opponents they said, there was this the accident in the '86, and a mass of quantity of radioactive material was expelled to the atmosphere. This site map for me is really important because the area was close in a radius of 30 kilometers, and all the people that were living around the radius of 30 kilometers had to leave, right? So you can see up the border with Belarus, and in the center is Chernobyl. Here you can see another site map. On the right, it's the Chernobyl site, reactor 4, And on the left, you can see Pripyat. That's the city that was most affected by the accident. So I decided a project to live back again in Chernobyl, because after doing some research, I found like a lot of people wanted to visit the area. Like scientists wanted to do some research, visitors, tourists, and also people that belong to there. And the most important also, there were a lot of workers that had to go every day, because it is said that until 2040 there are like more like a lot of people, a lot of workers have to go. So I designed, this is a design of a dress that people could move around. Also, I have a dispositive for scientists to move around Chernobyl, and also this is a prototype to live in for 4 or 5 people, like inflatable structure that we could install in extreme environments affected by radioactivity. And well, here you can say going to a bigger scale. One of the things that I did was to study the protocols that there are in a nuclear plant, what protocols they have when you get into the reactor, right? Like in terms of cleaning, in terms of measuring the radioactivity in the body. So I studied the protocols that they have, and I applied it to the project. So in this case, it's the opposite. Outside, it's affected by radioactivity, and inside, it's the radioactivity is reduced. But because I have to say, like, we cannot stop radioactivity, we can reduce its exposure. So nowadays, well, now the situation is really tricky because of the war, but before the war, you were allowed to visit for 30 minutes. So how we can extend that limit of time of exposure and reduce the exposure of radioactivity? Instead of being there for 30 minutes, workers could be there for 5 hours, and the radiation is reduced. So then going to a bigger urban scale, here you can see like we have my proposal, like is dealing with the persistence of the architecture of the city of Pripyat. And finally, here we have a section of one of the cells. And I was really interested in also do some research on ways of farming in radioactive environments, how we can cultivate crops in areas affected by radioactivity. And another thing I did that you can see is I covered the dome and I studied the what objects or what is the material that is used in the nuclear industry, and I applied it to the proposal. For example, a mask is done with some filters. How if we scale that filters into the scale of a bubble of an inflatable or a dome, and we could stop the small particles of radioactivity from outside. So in this context, I was really impressed about radioactivity and about the ecosystem in Chernobyl. And here is an image of the red forest. And one of the things that it was really interests me is about nature, right? How nature reacted positively to the effects of radioactivity. There were like animals, plants that were adapting to radioactivity. In this situation, I found a living organism that was found in the area close to Chernobyl, that, as the other Kate and the other speakers said, and I was really impressed how nature reacts to this with the presence of the black fungi or radiotrophic fungi. And I asked myself, what is my role as an architect? How as an architect we can learn from these living organisms, how we can take advantage, and how we can design infrastructure, or we design a proposal for using the properties of the flag fungi. These images I did last May at Johns Hopkins University together with Radames at his lab. And as you already know, and some of them explained before, like the important is the melanin, like the black fungi transforms the energy, the radioactivity into energy for its growth, and it's because of the melanin. The melanin is the translator. So here, as you already know, the melanin is really important because is like the machine that transforms it. So there are two important concepts in understanding the function of this living organism. Is radiotropism is the phenomenon where a living organism approach to the source of radioactivity, and radiosynthesis, that as we have plants that they have photosynthesis, here we have a living organism that produces a radiosynthesis. So one of the things that I ask myself without little knowledge about how it works is how its reproduction. It's through a spore germination. And I thought, okay, how if we help the reproduction of these fungi in radioactive environments, and what would happen if we built a tower or an artifact that has crops cultivate these fungi, and we help the reproduction. And one of the questions I also made is what would happen in radioactive environments if we increase the reproduction of these fungi after 10, 15, 20 years? The radiation will be reduced. That's something like still we don't know. As Trisha said yesterday, it's really important this collaboration and in multidisciplinary projects where we merge design, art, architecture, and science. I think even though sometimes we don't know the solution about a project, in the process of developing that idea, we can find out a lot of things. In 2017, thanks to the government of Spain, I got funding for a really small budget for developing a first prototype. And the idea was really simple. It had a sensor, a Geiger counter, that measured the radiation in the art gallery, because this was part of an exhibition, and the radiation and the fans were activated when radiation levels were really high, right? So that's the system I did. It's really in 2018 I got in contact. One of the things that I did, it was who are the scientists, are researchers doing studying this phenomenon. So I found like one group, like they were published in the 90s with Sadanova. Like she's the one that found the radiotropism phenomenon. But then I found, like in 2007, Arturo Casadeval was publishing about the properties of and the melanin. I got in contact with them, and this is how I met Radames. And I want to thank him also for his help and supporting the development these past years of this research. These some images that in his lab in 2021 and 2023. And this image is really, as I said before, Geiger counter. As I said, radioactivity is invisible, and the way we have to represent or visualize or understand radioactivity is through this sensor. So all the prototypes that you see here in the lobby, and I try to do, all of them, they have a Geiger counter, because it's a way for me to see the radioactivity. Here I can show you one of the prototypes that are also in the lobby, and it's like the evolution of the first I did. and it's kind of a tower where we have the Geiger counter and also the samples, and the fans where we could have the samples of the fungi. Here you can see more images, and then after I developed the tower, after discussions with Radames, we decided, okay, how if we use dry fungi? And I developed this other one where we could have the dry fungi and radiation. When radiation levels are really high, it spread out the spores in dry, and then and we can put it in the in a radioactive location. So one of the things that I've been doing also is what applications we could have, because we know we have nuclear plants, we have nuclear waste storage sites, and also we have the space where we could apply and use these artifacts. And also I want to say, like, this project could create a safer life for astronauts, military service, hospitals, nuclear plants, but still I need to do a lot of research on this and find collaborations with people from other disciplines. And I want to end my talk with this visualization. This is one of the towers, like we designed in the Chernobyl forest, and let's see what would happen if we display them around Chernobyl after 20-50 years, and if the radiation levels will be reduced. Thank you so much.